What level of sophistication does China's carbon-based chip possess? Following a ban by the United States government on the Huawei chip, the controversy surrounding the chip was confined to the topic of the commotion. Many companies that rely on United States-made equipment, software, and technology will be unable to supply parts to Huawei. Some chip foundry companies are unable to continue to OEM Huawei chips because of financial constraints. This event has brought China's attention back to the necessity of domestic chips that are independent and self-sufficient. Despite the fact that China has put a lot of effort into chip research and growth over the past few years, there is yet to be a breakthrough in some of critical technologies. As a result, China's chip research and development are still experiencing significant hurdles. Even though China has fully localized some low-end chips, the country's high-end chips, particularly high-end chips above 7 nanometers in size, are still entirely reliant on imports. Even if companies like Huawei have the capacity to design a 7 nanometer or even 5 nanometer chip, they not only want to convert this design into a real visible chip, but also want to entrust it to TSMC for manufacturing. The United States has now placed restrictions on Huawei. There is a great deal of ambiguity around the future of the 7 nanometer semiconductor. Unless the United States eases limitations on Huawei in the next few years, the company's future is likely to be adversely impacted significantly. Despite the fact that China has a significant technological deficit with the top worldwide level in silicon-based chips, and even everywhere in the high-end chips, a recent advance in China's independent research and development of carbon-based chips, however, indicates that the technology will be viable even without UV lithography in the future. China may also be able to create a small amount of high-performance semiconductor stock. According to the Chinese Academy of Sciences, a team of carbon-based nanotube chip developers led by academicians Peng Lianmao and Professor Zhang Jiyong has achieved significant research results in the field of new carbon-based semiconductors. The team's accomplishments were announced on May 26, 2020, in Science on May 22, 2020. An article entitled High-Density Semiconductor Carbon Nanotube Parallel Arrays for High-Performance Electronics was released. Among others who contributed to this work are Li Junliu, a 2015 PhD student in the Department of Electronics, and Ji Han, an engineer at Beijing Yanqing Institute of Carbon-Based Integrated Circuits. The co-first authors are Zhang Jiyong and Lianmao Peng, who are also co-corresponding authors. Several polymer dispersion and purification procedures were employed by the group in order to acquire ultra-high purity carbon tube solutions, which were then combined with a dimensionally limited self-alignment method in order to prepare carbon tube rays. China has not only broken past the bottleneck of carbon-based semiconductor production equipment, but it has also risen to the top of the global leaderboard in the technology for manufacturing carbon-based nanotube transistor chip technology. Carbon-based chips outperform traditional silicon-based chips in terms of power consumption and cost, as well as overall performance and reliability. In the opinion of Professor Peng Lianmao, carbon-based chips with the same grid length ingest at least 3 times less power and run 3 times faster than silicon-based semiconductors. It is expected that chips made of carbon tubes will be used in cell phones and weapons for base stations in the future. So how efficient is this carbon-based computer chip exactly? Peng Lianmao led a team to build a high-performance gate-length carbon nanotubes CUSOS device in January 2017, which is the world's smallest high-performance transistor to date and is the world's smallest high-performance transistor to date, with overall performance that is 10 times better than the best existing silicon-based transistors. They are on the verge of reaching the theoretical limit. Despite the fact that it operates at a pace 3 times faster than Intel's current state-of-the-art commercial silicon transistors, it consumes only a fifth of the energy of silicon transistors, according to research published in Science. This indicates that if a future carbon-based chip tube can be mass-produced, it will allow China to wean itself off of its reliance on Western silicon-based chips in the near future. In recent years, China's level of science and technology has significantly improved as the country has progressed into the information era. A number of key technologies have been mastered by China in a variety of disciplines, and the gap between China and certain industrialized countries is becoming increasingly narrower. However, it should be highlighted that photolithography is still a critical piece of technical equipment in China that must be addressed promptly if the country is to continue to build its chip manufacturing industry. Photolithography is something with which I suppose we are all familiar. It is a critical piece of equipment in the chip production process. Without photolithography, it is impossible to manufacture any chips, which is common information throughout the whole semiconductor industry. Previously, the majority of the population had never heard of photolithography. Nevertheless, the influence of the watch chip issue has caused China to recognize the significance of photolithography. This is due to the fact that Huawei does not have the production capabilities and must rely on an outside foundry with US technology to supply the chip. Furthermore, China is in a relatively weak position in the field of chip production, despite the fact that it is capable of producing low-end chips on its own. Huawei is experiencing a shortage of chips as a result of the loss of foundry partners, which exacerbates the limitations of the company's homegrown technology. In truth, China's strength in the design and packaging of chips is very strong, and it does not lag behind other countries in any way. People are rendered useless, however, because of a lack of photolithography support in China, which has resulted in the country never being able to entirely overcome chip production. China made the choice to completely lay out photolithography in order to further encourage the growth of domestic chips and assist in getting the country out of its current predicament. In this regard, it is understood that China's highest level of science and technology institutions, the Chinese Academy of Sciences, has been moving in this direction, and that the future will be centered on the ability of the entire institution to dominate lithography and other technologies that are easily conquered by foreign competitors. It may be anticipated that, with the support of CAS, the domestic lithography machine will undoubtedly continue to advance and that this problem will be resolved in the near future. And not only that, but the Chinese Academy of Sciences recently revealed that two technologies had achieved a breakthrough in their respective fields. The complexity level is comparable to that of lithographic printing. In other words, in adding to lithography, the Chinese Academy of Sciences has successfully conquered two technologically challenging fields of study. The first technology is a new OLED display material that has been developed. The Chinese Academy of Sciences, led by academician Li Yadong, is a prestigious institution in China. The project for mass production has already begun with the laying of the foundation stone. Despite the fact that Chinese screen makers BOE OLED materials have conducted considerable research, there is still a significant gap when compared to Samsung. The Chinese Academy of Sciences has rushed in to fill the void left by the absence of the Chinese Academy of Sciences. Possibly it will not be long before a domestic OLED panel can be produced in place of the Samsung OLED screen, which is currently used in cell phones, laptops, and other electronic items and is considered an industry standard. Thus, the research and development activities carried out by the Chinese Academy of Sciences or CAS are required. It is possible for a household screen to occupy a broader market and thus gain more development space as long as it can be recognized by the public. The second innovation in CAST technology, which is related to chip, gives a new advancement for domestic semiconductor manufacturers. According to reports, the Shanghai Institute of Microsystems of the Chinese Academy of Sciences has demonstrated the first 8-inch graphene wafers, which are now ready for mass production. In other words, China is currently dominating the world in research on carbon-based chips, and if the wafers can be cut precisely, a true carbon-based chip will be formed shortly thereafter. Throughout the entire process, silicon-based semiconductor materials have been used in the chips, and despite the fact that their overall performance is still excellent, they will be unable to make further development as long as they approach their limits. So many countries around the world have begun to focus on carbon-based chips because their performance and stability are stronger. Once a breakthrough is achieved, the semiconductor industry will undoubtedly undergo significant changes. In the sector of carbon-based chips, it appears that China has surpassed the United States as the market leader. The introduction of 8-inch graphene wafers represents the possibility that the local chip may be able to overtake the foreign chip, but this is not enough. To be successful in the emergence of domestic chips, it is necessary to keep moving forward. Carbon-based chips and silicon-based processors are also slated for confiscation. The two good news released by the Chinese Academy of Sciences for Domestic Technology has significant implications not only for the development of many Chinese firms, but also for the development of the country as a whole. And I hope that someday, China will be able to consistently break through numerous fundamental technologies and realize the objective of becoming a strong country in the scientific and technological department. For the time being, We can only wait and observe what initiatives China is going to take towards making a better world. With that said, we have reached the end of today's video. What are your thoughts on this one? Let us know down in the comments below. Thanks for watching guys, and just before you leave, make sure to give this video a thumbs up and subscribe to the channel if you want to see more content like this one. Take care, and I'll see you in the next one.